So for the next lesson, we are going to learn about inscribed triangles. So the last lesson we learned about inscribed angles. In this case, we are going to learn about inscribed triangles. So we're starting out with a lab. We're going to actually kind of try and figure things out for ourselves here. So for step 1, it says use your straight edge and draw the inscribed angle GHB. So we have G to H, H to B. It says, what arc does GHB intercept? Well, let's look. GHB intercepts this arc here. So we could say arc GEB. It says, what is the measure of this arc? Well, let's think about this for a second. What is line segment GB? Well, that's a diameter, right? So if that's a diameter, we know that arc GEB has to be equal to 180 degrees. And the reason for that would be because it's a semicircle, right? Next, it says, what is the measure of GHB? Well, if we know that the intercepted arc here is equal to 180, how much would my inscribed angle be equal to? This is 180. My angle has to be 90, right? So 90. Now it says draw on diameter GB, which I had already had. I'll put it back in there. We have diameter GB. It says what kind of triangle is triangle GBH? And hopefully you guys know this, right? Hopefully you're thinking it in your head. That's a right triangle. And for question 5, it says the diameter of circle A is known as what in GBH? Well, that's our hypotenuse. Right? This would be right here. Let's see, I'll highlight it in a different color. We'll go green. This is our hypotenuse. So in this case, the diameter, in this case, the diameter is the hypotenuse. So, big idea, inscribed triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of a circle. Okay? And this is only true if there is a diameter. Right? You have to have this be the diameter in order for this to be a right angle. And if you think about it, it makes sense, really. If we're looking here, we know that a diameter makes a semicircle. Because of that, the intercepted arc is equal to 180. So automatically, this inscribed angle is going to be 90 because we know inscribed angles are half the measure of the intercepted arc. So hopefully that helps kind of bring it all together for you. So let's go ahead and do some problems. Now for these, I really want you to actually treat some of these as practice. I'm going to do, a few of these, but I want you to actually see if you could do them. All right. So I'll show you this one, and then we'll see if you can kind of get some done for yourself. So for example 1, it says use the diagram to answer the following questions. Here it tells me to solve for x. So if I'm looking at this circle, and one thing I kind of want to point out to you guys is when you're approaching these problems, really, you've been given tons of different little bits of information, right? At this point, we know the triangle theorem, we know inscribed angles, we know central angles, we know arc length, we know area of a sector. There are so many different things we've learned in this unit, and you really have to stop and ask yourself, okay, well, what is this problem giving me? What do I see here? What do I have to work with? So if we're looking here, I automatically see an inscribed angle here. Right? That's an inscribed angle. They gave us the measure of the inscribed angle, which is 40. So if the measure of my angle is 40, my arc has to be twice that. So I just do 2 times 40, which is going to give me 80 degrees. And that's what x is equal to. Now this next part's a little tricky, and it requires you to kind of keep in mind what we just learned. If we look at this triangle, this diameter is the hypotenuse, right? So that means that this semicircle here is equal to 180, which makes this intercepted angle equal to 90. So then if I'm trying to find my missing angle here, I could go ahead and do 180 minus 90 minus 40, which gives me 50 degrees. And I know that my intercepted arc has to be twice that. So y is equal to 100 degrees. Now, there's another way you could have kind of approached this. We also know that this semicircle has to be equal to 180. And since we knew that x was 80, we could have done 180 minus 80, which gives us 100 degrees. So we could have gotten that 2 different ways. Now for example 2. I want you to see if you can do this one, right? Think about what you know about diameters and how if you have a diameter and an intercepted arc and in the inscribed angle, think about the relationship and see if you could figure out what y is equal to. And then see if you can figure out and solve for x and x. So go ahead, pause the video, see if you can figure it out. So for example 2, it says if SA is the diameter, then what angle measures 90 degrees? Well, we know that our 90 degree angle would be y, right? So we could say y equals 90 degrees. Now it says go ahead and solve for x. Well, we know that x plus y needs to equal our 180, right? Because they're all the angles within a triangle. And in this case, we know that y equals 90. So we actually have 2x plus 90 equals 180. So you end up with 2x equals 90, x equals 45. Now it says, classify triangle SEA by its sides and angles. Well, we know that x is 45, so this angle's 45, this angle's 45, and this is a 90. Well, I've got a 45, 45, 90, right? All right, so again, this is a great time for you to pause and try this problem by yourself. See if you can figure it out. So for example 3, it says, use the diagram to answer the following questions. If AD is the diameter, then what angle measures 90? Hopefully at this point, you're looking at it and you're like, well, I know my 90 degree angle would be x. Or we could even say angle ABD. Then it says set up and solve for y. So I know that all these angles, because of the interior angles of a triangle, need to add up to 180. And since I know, well, I'll say x plus y plus 35 equals 180. I know x is equal to 90. So when I go through and I solve, I end up with y equals 55, right? You would just do 180 minus 35 minus 90. You end up with 55. All right, almost there. So next question, it says if AB is 15, so they're telling me the measure of this is 15. And then they tell me that AD is 25. That means that this guy is 25. They say, what is the measure of BD? So this is the guy I'm curious about. Well, guess what? We've got a right triangle, and we're looking for a side length. We are going to use Pythagorean theorem. A squared plus B squared equals C squared. And this here is going to be my C, because that's my hypotenuse. So I just do 15 squared plus B squared equals 25 squared. So I get 225 plus B squared equals 625. You subtract out the 225 and you get 400. Take the square root of both sides and you get B equals 20. So we know that BD equals 20. All right, so I know I just threw a lot of information at you. Kind of digest it. See if. All right, so for example 4, if AB is the diameter, what is the angle, or which angle measures 90 degrees? So we have AB as the diameter, so we know that our inscribed angle here is going to be our 90-degree angle. So that's going to be angle C, or we could say angle ACB. For B, it says set up to solve for x. Well, since we know that that angle is equal to 2x, and we also know that that angle is equal to 90, we could say 2x equals 90. So x is going to equal 45. Next, it says, what is the measure of angle BAC? So if we're looking here, we have angle BAC. Well, angle BAC is an inscribed angle with its intercepted arc being 120. So we could say that this is maybe y. We know that 2y would equal 120. Y is going to equal 60. If this kind of setup confuses you, just always remember that the angle measurement is going to be half that of the intercepted arc measurement. So the arc should always be bigger than the angle. Put a little degree symbol. Next it says, what is the measure of ABC? So there's kind of different ways you could approach this. One of the easiest is if they're asking for ABC, that's just asking for the third angle measure in this triangle. We know that this guy is 90, this guy is 60, and hopefully you remember from our special right triangles, this would give us a 30, 60, 90. If you didn't remember that, what you could just do is 180 minus 90 minus 60, which would give us 30. So you know that that is 30 degrees. Now, just kind of another way to approach this is we know that BC is 120, and we know that this entire part here makes a semicircle, so we could do 180 minus 120, and that would give us that arc AC is 60. So that would mean that angle B would have to be 30 because it's half that measure. That's just another way to approach the problem. Now, for E, it says what kind of triangle is ACB? Well, we talked about this, right? It's a 30, 60, 90. And then it says if AC, I'm going to erase all my work. If AC is equal to 4, what is the length of the diameter? So they just told us that this is equal to 4, and they want to know what this diameter is equal to. Now, if you recall, kind of the setup for a 30, 60, 90 was this. So AC would be equivalent to this x side. The AB side is equivalent to the hypotenuse, which is 2x. So if AC is 4, that means AB is going to have to be 8.